In the first lecture on the muscle in general anatomy series, I told you that the one of the important property of the muscle is the contractibility. That means a muscle can contract, okay? And this is possible because of the actin and myosin filaments which are present in the muscle. But this muscle contraction, which because these are the skeletal muscles, they are attached to the bone. When they contract, they produce the movement at a joint because they move the distal bone from the side of insertion of the muscle. Okay. Now, these movements which are responsible for the locomotion of the body, okay. Now, if you see the muscles present in the various parts of the body, then you will realize that at certain places in the body we need the contraction of muscle which is very powerful, okay. The powerful contraction is needed, okay, where you do the I mean to say strenuous work is needed. But at the same time, you must have noticed that some of the functions are the work, say for manipulative work, the fingers work which are there, muscles which are moving the eyeball, they don't need any power, okay. I mean say minimal power is required, but yes, then the precision of the movement is necessary, okay. And this all different kind of the movements are performed by the skeletal muscles, okay. Now we will see in this lecture, okay, about the some facts about the muscle contraction, okay. So this is an lecture which is usually asked in short note, okay. Let us see the some facts about the muscular contraction. Okay, there are two important aspects in contraction of the skeletal muscle. Okay, which are these two important aspects in the contraction of skeletal muscle? One is the power or force of a muscle. As I said that some functions they need the power. Okay, so some muscles they can well, while they are contracting, they generate the power. They become, I mean, so they are very powerful. Okay, or their force is contraction force is much more as compared to other muscles. Okay, and then second thing which we observe in a muscle contraction is somewhere the muscle. Okay, we need the range of movement. Okay, we don't need the power, but the movement range of movement is required. Say for example, the flexion and extension or the elbow joint, okay, where the upper limb, I mean say the forearm moves towards the arm in the flexion movement, and this covers a wide range of movement from straight upper limb, okay, then the elbow joint begins to flex or begins to bend, and then the forearm comes close to that of the arm, okay. So there is a range of movement, a wide range of movement is possible because of the contraction of this muscle. So these are the two aspects of the contraction of the muscle, power and the range. Let us come to the power of a muscle, okay. The power of a muscle depends on the number of the fibers in a muscle, okay. And number two, it also depends on the diameter of the individual fiber. That means if the number of fibers are more in a muscle, and if they are of thick, these fibers are thick or their diameter is more, then the muscle will be a powerful muscle. Okay, in the last lecture where I showed you that there are multipinnate muscle, and multipinnate muscles, I told you that their length is less, okay, the length of the fiber, but then number of fiber is much more, okay, okay, because their length is less but the number is more, okay. And because of the obliquity, lot many more fibers can be accommodated in a single muscle, okay, in a single muscle. And at the same time the diameter of the individual fibers is more in those muscles where you have to do the strenuous work, okay, which are involved in the doing the strenuous work. For example, when a person is doing extraneous exercise in gym, then his muscles they get more thicker. That means thicker means, okay, if the diameter increases, the number of the muscle fibers though remain the same in a muscle, but their diameter increases because of the repeated exercise. Okay, for prolonged period, if somebody is going to a gym and doing the exercise or any other exercise, you have seen that the muscle become I mean say visible. Okay, especially the muscle of the thigh, the muscle of the calf, the muscle of the joint, shoulder joint, okay, the muscle of pectoral region, they become very prominent. Okay, now this is because there takes place the hypertrophy or the increase in the diameter of the individual fibers. And why the individual fibers diameter increases? Because of the exercise, prolonged exercise. The reason is that more and more new actin and myosin filaments are added to that muscle fibers, and that's why the diameter of the fiber increases. Okay, now second aspect of the muscle contraction is the range of movement of muscle. Okay, it is the range of movement of muscle, and this range of movement of muscle depends on the length of the muscle fiber. If the muscle fiber are long, then their range of movement will be more. Okay, if the muscle fiber are short, the range of movement is not more, but they are powerful muscle. That thing you should be clear in your mind. Okay, okay, as these muscle they contract up to 40% of their length. That means the muscle belly can reduce to 40% to its original length when it is contracting, right? Say for example, if the length of the muscle belly, not of tendon, because tendon is not non-contractile. Okay, when the if the length of a muscle belly is 10 centimeter, and when it will contract, then it will reduce to 60 centimeter. Okay, that means there is a reduction of 40% into the length of the muscle belly. Okay, on the other hand, the deltoid is a powerful muscle. That means the range of contraction is not much. It is the very less. Okay. Then on other hand, the biceps, which is present in front of your arm, you just feel your arm in front of the arm, the muscle which is present in biceps, and when it will contract, what it will do, it will just bring the forearm towards the arm. That is, the flexion movement will take place at the elbow joint. So here the range is more, because here the length of the fibers in biceps is quite long fibers. Okay, so you have now understood on what factors the power of the muscle depend, and how the range of movement is dependent on to the length of the muscle fiber. So when we have read in the last lecture about multipinnate muscle, the muscle length, fibers length was short, very short. But when we have read the muscles which were arranged, where fibers were arranged parallel to each other, okay, though they were strap muscle, ribbon muscle, okay, or other muscles, fusiform muscles, so we have read about those muscle. They were, I mean to say, their length of the fibers running parallel to each other were much longer. Okay, much longer. Okay, so they are involved in the wide range of movements. Okay, it's possible because of the contraction of those muscles. So muscle, they, I mean to say, they adopt that capability. That means they become multipinnate when power is needed, and they become long with the long fibers, parallel fibers, where the range of movement is needed. I'm moving to the next slide. Right. Now, in some fact about the muscle contraction, we are going to learn an important fact, which is, as I said, is an important short note question. So be attentive. Now, the force of action of a muscle depend upon the site of its attachments. That means site of the proximal attachment, to which we have said that it is called as origin, and the site of the attachment, distal attachment, to which we also call at insertion. Now in this diagram you are seeing a muscle which is attached almost in the middle of the proximal bone, when its insertion through the tendon is also taking place almost in the middle of the distal bone. And as a rule, I said that a muscle has to cross at least minimum one joint. So this is crossing a joint. Say for example, it is an elbow joint, then this will be the humerus bone and this will be the ulna bone. Okay, so just remember this. Okay, now see the site of the origin and the site of the insertion. Okay, because this action depend on the site of its attachment on proximal as well as on the distal bone, whether it is going to do what kind of function is going to perform. Now if insertion is in the middle of the distal bone, this is the distal bone, and you know what is proximal and what is distal. Okay, so it is the insertion is taking place almost in the middle of the distal bone, and origin was also from the distal bone. Okay, now when this muscle will contract, then it will pull this bone, distal bone, that means ulna will be pulled towards the humerus in the movement of the flexion at the elbow joint. Okay, at the elbow joint. Now when these forces which are acting on the ulna in the middle of the ulna, they can be resolved into two different components. Okay, now see this arrow, which is here, it is written as the swing, and see that arrow here which is written as the shunt. Okay, this the so it can be resolved into two component of forces. One is swing and another is shunt, and both these components, swing and shunt, they are at right angle to each other. Okay, what will happen due to this swing component? Because of the swing component, the movement will take place at the elbow joint. That means this ulna will be pulled in the direction of this arrow. Okay, so this swing movement will produce the movement of flexion, because say for example, if it is a biceps muscle, okay, so it will bring the ulna towards the humerus at the elbow joint. So flexion is taking place, movement is taking place, and this is because of the swing component of the action of the muscle contraction. Okay, the other component which is at right angle to it, it runs parallel to the distal bone and it is running towards the proximal side. And what is there in proximal side? There is the presence of a joint. Okay, there is present. So this pull of this component of the force will just keep the upper end of the ulna close to the lower end of the humerus. That means it will produce an stability in the joint. Okay, joint will become stable when the movement is taking place. I hope that the two component you have understood. One is swing and another is shunt. And what is there? Swing produces the movement at the joint. Okay, and the shunt produces the stability in the joint between the two muscle, or I'm sorry, between the two bones to which this muscle is crossing. It is humerus and the ulna in this case. So remember these two components, swing and the shunt. Now we will see the different condition of the muscle attachment. Okay, and what are these components in those conditions. Okay, so I am moving to the next slide. Now, what is here? Here is that the origin of the muscle or proximal attachment of the muscle is close to the proximal end of the proximal bone. Okay, that is on humerus. It is close to the upper end origin. And if you will see its tendon, this is crossing the joint and then getting attachment very close to the upper end. So the insertion is also at the upper end of the distal bone. Okay, distal bone. And when this muscle will contract, then these two forces, that is the swing and that of the shunt force, see this is swing component and this is the shunt component. These two components are there, okay, because of this force of the contraction of the muscle. Now but since the tendon is very close to the joint, in the previous case the tendon was in the middle of the bone, distal bone. Here the tendon is attached very close to the joint, okay, on which this muscle is going to act. Therefore the the function of the swing, that is the movement function where the flexion movement will take place, okay, that is more prominent. That means if you want a more prominent action of the muscle in the form of the movement at the joint, then the insertion should be close to the joint, okay, on the distal bone, close to the joint on the distal bone on which this movement is taking place. Here it is elbow joint, okay. And this kind of the muscle which are powerful in their movement are the swing action. In the swing action, they are attached close to the proximal end of the distal bone, and this kind of muscle they are called as spurt muscle, S-P-U-R-T, spurt muscle. And this I have indicated by a thick arrow, because the other component which is parallel to the bone and going towards the joint was the shunt component. This component is weak, okay, when the muscle is attached close to the proximal end, okay, this component is weak, so that the shunt component which provides the stability to the joint is a weaker component, okay. So depending on the what the muscle is doing is depends on where it is inserting. Those muscle which are close to the proximal end of the joint, they are producing powerful movement at that joint, okay. And those muscle which are away from the proximal end of the distal bone, they are will be producing the shunt component. Very, I mean say, is very major component is there. So stability of the joint, that I will show you in the next slide. So I hope you have followed the spurt muscles, okay. Now we go to the second. Now I come to the second kind of muscle, which is called as the shunt muscles, okay. Now here you see the attachment of the muscle, right? Okay, let me bring the pointer here. You see the origin of this muscle, shunt muscle, which is close to the distal end of the proximal humerus, say for example, and this muscle is running now parallel to the distal bone, okay, and then it is inserting, its tendon is inserting very close to the distal end of the distal bone, that is onto the ulna. It is just different than the previous muscle which we muscles which we call as the spurt muscle. Now here this, if you resolve this component of the forces which are acting on the distal end of the distal bone, then you can see this is the shunt component, I mean say this component which is red here going upward was the swing component, and swing component in this case will be very weak, okay, it's very weak. But if you will see another component, okay, which we were saying as the shunt component was here, this is the very powerful here. So these kind of muscles which are attached close to the distal end of the distal bone, say for here ulna, they are called as the shunt muscle. So there are two different types of muscle, spurt muscles and the shunt muscle. And what is the function of the shunt muscle? Since their component of the shunt component is very powerful and they are directed towards the bone, I mean say towards the joint between the two bones, this joint become very stable because of this pull of this muscle from their distal end, okay. So they provide the great stability or strength to the joint, okay, to the joint. An example is the brachioradialis muscle. When you will go to the upper limb and will dissect this muscle in the arm, this muscle starts from the lower end of the humerus and runs parallel to the ulna and goes and gets attachment to the styloid process, just I mean say close to the styloid process of the radius, okay, not to the ulna, that is other muscle bone which is present there, okay, that is brachioradialis, okay, that is brachioradialis. So it is attached to the radius, and this muscle is very close, just above the styloid process, okay. So throughout its course, this muscle is parallel to this bone. Say for now, the bone is ulna, but you imagine that it is the radius, the lateral bone in the forearm. Okay, so because of its parallel running, it pulls when it contract, it will pull this distal end of the radius towards the elbow joint, and thus it provides a strong stability to the joint. So these kind of the muscle are called as the shunt muscle, but they are weak in the movement. The movement which brachioradialis produces is a flexion and slightly, I mean to say, the pronation. Okay, it is also provided by uh, this muscle, right? So these are the weaker flexor, they are the weak flexor muscles are. So ultimately you have learned the two different kinds of muscle are the contraction of the muscle, that is the shunt and the spurt. Okay, so thus spurt muscles provide powerful movement, spurt muscle provide powerful muscle, but shunt muscles provide the stability to the joint. So in nutshell, you should remember this last sentence about the contraction of the muscle. And in initial part, I said that the contraction of muscle, it may be of two type also, where the power is needed, the multipinnate muscle. The length of the muscle fiber is short, but they are more in number and their diameter is more. Okay, and when the range is needed, then the muscles are elongated, long muscle, like the parallel running ribbon muscles. Okay, parallel running, as you have seen in the lecture of the classification. I hope you have understood this. Okay, thank you.